Welcome everybody, my name's Scott Hebbard from Sparx Systems and I'd like to welcome you to our webinar today. Today we're looking at infrastructure modelling and I'm joined by Richard Paton. Richard, I was just wondering if you could introduce yourself please.
Thanks Scott. My name's Richard Paton. I work as the Principal Systems Architect at John Holland. We are, as you know, are a construction company, historically dealing in large infrastructure projects. I work for the rail division, so I'll be focusing today on passenger rail systems, going through showing you how the projects are broken up. Usually the projects that we work on are specified by government customers, and they break up the project into several contract packages. Each package can be around $5 billion. And just as sort of an example of how it's broken up, this gives you an idea. Top left, we have station packages, and I don't know, at a rough guess, I guess underground station could be $1 billion. Rail systems packages over there on the right, so that would be fitting out with all of the electronics and control systems in the tunnels. Bottom left, tunneling packages, obviously a big expense, getting tunnel boring machines to dig 10-kilometre long tunnels, etc. underground. Systems integration on the bottom centre is about the control systems that bring it all together and make it work as a railway. And then increasingly an area that we're getting involved in over on the right, it's called a train graph, but that represents running train services. So actually operating and maintaining a train system. We're partners, for instance, in MTM as a rail operator in Melbourne, providing metro services in Melbourne. So each of those groups I showed on the previous page are usually selected by the customer as different contractors, and what we do is represent the various systems in the station as I've shown here. So we've got a railway station, and here we've got an equipment room, and down the bottom is a tunnel. Each one of these areas, each one of the systems, etc., they're allocated to a particular package contractor. I've shown on the right here how we represent the package contractors that are responsible for a particular system. So the state usually breaks up the delivery by life cycle. So we've got specify, design, supply, install and commission, install and construct and test and commission. Each one of these little boxes can be assigned to a different package contractor, and we've got different colors there. So you can see this box down the bottom in the center, showing that the blue guys, station, are responsible for specifying, designing, supplying, install, test and commissioning of that particular thing. So we have the station contractor responsible for the station stuff. We have down here in the bottom left, we have the tunnel contractor responsible for the tunnel, as you'd expect. And there's an interface between the two. And of course, that interface between the two, being a inter-package interface, is complicated by all the commercials that need to go across that interface. Within Enterprise Architect, we keep the assignment of responsibilities as tags within EA against each item. So I'll show you a complicated page. This one here shows you quickly, I guess, how you can create your own modified version of the stereotypes to represent the scope as we've got it there. This is done using EA Enterprise Architect version 17, which has a simplified thing, which we'll show you in a sec, to create the profile. So the first step is to create the profile. I usually, for a simple thing, once off for a per project, create it within the project itself. And if you create it as a top level model element, you can hide it from other users, so you can keep it as a responsibility for the administrators, not let people go around fiddling with it. Having created using the technology builder to create the template, you then go into the profile helpers area and add a stereotype. And you can see here I've created a stereotype called Sparx class. Once you've created that object, go into the tag values area and create a property to hold the value that you want to display. So here I've called my property D space design. The next job is to go into the shape script area and create a shape script which says this is what I want it to look like. There's a load of magic code in here. You can just copy and paste it in, but basically it just, you can see the essential bits here. If it has a tag D design and that's set to me, then it'll set the color to that particular color. If it's D design U, then it will specify a different color. It'll fill it in with a different color and print the D letter in there. You need to add the toolbox page, because without the toolbox page, you can't create your new class. So you go into the toolbox page and create and add the class you've just created. You then select the technology in the browser, and this is where EA17 has a nice handy cheat. You can come up to the Specialize menu, Import Packages MDG Technology, and click on that, and it creates the technology and imports it into the model. You'll then have in your toolbox a Sparx class, which you can then plonk on your diagrams with a tag, fill it in, and you'll end up with those sorts of representations. So this is an example of the use of systems and locations. So here we've got a load of systems. We've got some rooms. We've got some in the rail stations. We've got some various systems. You can see here that it doesn't have to be a single package contractor that's responsible for the entire life cycle. Here we've got the integrator responsible for specifying and designing and for testing and commissioning, but the station contractor responsible for supplying and installing. So that would be a fairly common way of working. The interfaces, we've got connecting all of the different elements through here, data, functional power, whatever. We keep it fairly simple. This line here is an interface which is what we call space proofing. So it's a very important early interface, because it says how much room do we want in that room to be able to support the systems in there. The reason that is so important is because for an underground train station, space is very, very, very expensive, and if you get systems contractors that come in and say, well, we need 70 square meters of room, they really need to have something to back that up, because that's a lot of space. And similarly, if they go and underspecify, then we've got a problem, because we can't fit the equipment into the room. So that is a very important interface there. Once we've established the interfaces, I've got a script which I run, which just runs through the diagram and gives everything a unique number. The unique number is important because that's what's going to be referred to from here on, and it's guaranteed to be unique within the model. This diagram here shows various interfaces between different packages. These ones here are usually controlled by the state at the government level. They specify what you must document on those interfaces. They're contractual, so they're a lot more risky and important to capture. Now, there's an important point I want to make about infrastructure projects. Our systems are not complex. So if you have a look on this diagram here, there's a whole load of items here, which are commercial off-the-shelf things. So all of these things here, the train, platform screen door control system, platform screen doors, they're all standard off-the-shelf things that you can go to, admittedly a specialist supplier, and they will provide those things. They have the solution. You buy them, you put them in. Over here on the left, these other systems I've got here, I've got LV, earthing and bonding, HV system, and track. These are standard, again, standard discipline engineering items. LV system is something your electrician will do to build your house at home. Earthing and bonding, ditto. HV system, of course, it's not something you're going to have in your home, but it's a very common discipline around town. And track laying is similarly a very standard discipline. There isn't anything really complex about any of our systems. What drives our complexity are the interfaces. So I was talking before about these interfaces here, which are critical space proofing. These ones here drive your piling. This is typically done very, very, very early in the project. Like before you've even got the project going, you'll have some contractors in doing early works because it's critical path stuff to get that piling done. And you can't do the piling unless you know how much space you're going to need, but you haven't done your design. So it's a very critical piece of the puzzle. This interface here, this is the entrapment risk. So if you get this interface wrong, people will die. And if you look up entrapment risks with platform screen doors, there's been a whole load. I did a Google earlier on, and there's a whole load has been happening in Korea with people who get trapped between the doors and the train takes off. It's not good for their health. This interface here is the tunnel gauge clearance. This is what is important to stop the train from bumping into the tunnel. And there's been lots of cases of projects where they put the train in the tunnel and it has gone bump. The interfaces down the bottom here are also important because that provides the gap that people can slip and fall down in the gap between the train and the platform. We have interfaces up here between earthing and bonding and the platform screen doors. If you imagine that or understand that the train is actually powered by 22,000 volts. So it's being fed 22,000 volts and you're on the platform, which is at earth, and you're about to stick 1 foot onto the train. You can imagine that if something goes wrong with that earthing system, you're putting your foot from one side to the other, which could be a bad thing. That particular accident risk doesn't happen, not that I've heard of. It's a thing where you have to get it right, and that's why it's an important interface. So the point here is that the systems that we have here in the diagram are important, but they're off-the-shelf things. It's the interfaces that really are important for us. So understanding the importance of the interface, what the state has is a hierarchy. So in their contracts, they have some high-level interfaces, which they've defined. We then pick it up and say, okay, we're going to implement the station with a whole load of packages and the tunnel with a whole load of packages, and there will now be more interfaces. So for instance, the government defines 300 generic interfaces. By the time we've done our work, there's about 3,000. We then get down to more detailed level, and we're looking at about 10,000 implementation interfaces. And we have to track all of those, and we don't want to track them individually, so we need to be able to trace them up from here to more generic to understand their attributes. Unfortunately, tracing between one line and another line is a bit ugly. You do when you link two lines, there is an object called a proxy connector which is created on each line, but each link creates a new pair, and it's very hard to visualize and to track those. So what we do is, as well as drawing the line between the two, we keep an object which represents the same information in that line. So we have to keep a correspondence between the two, which we can do through scripting, but by then having each interface as an object, we can then trace the linkage between different layers. We can also assign issues, etc., to interfaces fairly easily because they're now an object that we can track to. So I think we're getting there. So using Enterprise Architect, we're able to represent complexity at the highest possible level. So we try and elevate the conversation as much as possible, simplify it. If we need to go down into the guts and represent data at a lower level, we can do so. We can represent the data in a way that's most meaningful to designers. So we need to pass all of this information off to disciplined designers who are not versed in the ways of SysML, which is what we're using to describe things. But we can tell the story in a way that they can pick it up and run with it. And this allows us to get the information, the consolidated system-wide information out to designers and into their design packs. That's it from me, thanks.
Excellent. Thanks, Richard. That was a fantastic presentation, seeing how it all comes together. Just had a couple of questions. First of all, what were some of the advantages and benefits of using Enterprise Architect for such a large infrastructure project? What are some of the things that you personally found valuable in the process?
So we started out going down this path. Initially on a particular project, we had 3 people who consultants. These are not dumb people, and they were trying to pull together the architecture from 3 packages. So a particular project had 3 packages. Each of those packages had their own architecture, and these guys were trying to pull the 3 architectures together and produce a document that said, here's what our railway looks like. The problem is that they were using Visio for the drawings, they were using Excel for the tables, and they were using Word for the words. Yep. And they were struggling to get the Visio drawings to match the Excel to match the words. And as soon as they managed to get things matched up, which took a long time, they would then bundle the document up and send it out. And the package contractors would say, well, yeah, it's nice, but it's wrong because we changed. And these things have changed. And they would have to go back and redo the whole thing. So the cycle of getting the data right and get a document out was so slow that it meant that they were always wrong. And after 2 years of trying to get it done, they still hadn't managed to get anything other than a draft out. We got Enterprise Architect in, and in the space of 4 months, learned how to use it, got all of the data from all 3 packages into the model, released the document, got it reviewed, updated it, and then reviewed it for use. And that was within 4 months with 1 person doing it. So, and from that point on, maintenance becomes so much easier. Yes. So that was just a toe in the water use of Enterprise Architect, and we've been building on it since then to get far more complex use of it.
Yeah, and this is not an uncommon scenario with many customers we talk to that are trying to move away from Word and Visio and Excel and trying to move their requirements and system specifications into a more robust modeling environment.
So and the important thing too is I think you don't have to solve the world's problems in one step. So every step you take, it's an evolution, learning how to use it, learning how to do it. If every step along the way makes economic sense, commercial sense, then do it, and you will gradually build up your capability.
Excellent.
Following
up on that, how did you kind of get the information from the model and the SysML and all of the content that you've created? How did you get that out to key stakeholders?
So the government structures, it's very commercial, so everything has to be a document. So we're stuck with everything needs to come out as a document. We're on projects now where we're doing a lot more online sharing, but ultimately at milestones, it's got to come out as a document and and get signed off. So
excellent.
yeah. We are looking to use Collaborate. We're waiting for purchase orders to come through, etc. So we're hoping to do a step change now.
Yeah, and I think that's fantastic. And the fact that you can use Collaborate and see all of this information in real time and get real time updates and engage more directly is fantastic. And final question. How do you kind of move between some of the high-level packages that you're talking about down to the low-level designs using Enterprise Architect?
So we have, well, I showed you, I think, some of these. Am I still sharing screen?
Yes, yeah, you're still sharing screen, yes. So.
Yeah, so here, for instance, are examples of the sort of systems we have. So earthing and bonding, LV system, track, platform screen doors. Those systems there are as far as we go with our modelling, and the reason is because there are discipline engineers who work in LV or in track design or in platform screen doors or whatever, and they will be producing a design pack. And a design pack can be anything from 100 to 4,000 pages long, depending on the complexity. And they will use whatever tools for their discipline to be able to design their thing. So we'll break up and say, hey, designer A and designer B, you both got a problem to solve. Here's your respective problems. Here's your respective interfaces. This is where you need to be doing things, etc. And off you go. You go and do it. They'll have their requirements out of doors. But we can say we're more like an orchestra leader than a detail designer.
Excellent. Well, thank you very much for this presentation. It's been great to see Enterprise Architect used to help facilitate such a comprehensive and amazing project. It's great to see that the actual components are off the shelf and simple, and that you've talked about how you've managed some of that complexity and looking at risk and things like that and how to manage that, and it's been great. So thank you very much for your time.
You'll be able to experience the outcome on the 30th of November because the government's just announced that's when they're opening the Metro Tunnel project. So
can't wait. I use the Melbourne rail system all the time, and so I'm looking forward to walking through those new stations, and it will be great to know that Enterprise Architect has contributed to.
Well, you'll be happy to know next time you catch the train down through Sunshine Station that's the one we're working on too, which is quite a complex little piece of work.
Fantastic. Very good.